Finally, in this unit post-production machinery, you will understand the importance of garment finishing processes. The final review section invites you to reflect on what you have learnt. By the end of this unit, students will be able to describe garment finishing, review equipment used and methods of pressing, review post finishing machines and equipment. Let us begin by understanding the need for ironing and pressing garments. Ironing or pressing is necessary to smooth away unwanted creases and crust marks. These are normally caused by bad operator handling. It is necessary to make creases where the designs of the garment requires them. For example, creases in trousers and in skirts. It is needed to mold the garment to the contour of the body. This is done for the enhancement of its shape. It requires two kinds of deformation, that is shrinking and stretching. After molding, it is not possible to return the garment to its original shape. For example, molding takes place or around the edges of darts, collars, shoulders, armholes and sleeve heads and sometimes trouser legs. Ironing and pressing are needed to prepare garments for further sewing. It is also called as under pressing. It is pressing operations on partly finished garments. It is also needed to refinish the fabric after manufacturing the garment and to give a final neat appearance to the finished product. Now, let us review some commonly used terms during garment pressing and finishing. Ironing is the process of cleaning or removing unwanted creases by use of steam and heat. Pressing is the process of use of pressure. A molding operation or process is an activity or activities in which heat, moisture and or pressure are used to change the density, form, shape and surface structure of an apparel, product or piece of fabric. Let us now learn about how garments are typically categorized before they are finished. The first type is garments which require no pressing. This category includes bras and other foundation garments, stretch swimwear and dancewear, briefs and other items of underwear. The second type is garments which require minimal pressing or finishing. This category includes garments which require no more than a light steaming, since pressing in the sense of applying pressure is not necessary. For example, nightgowns, slips, knitted synthetics, t-shirts and leisure wear. The third type is garments requiring the use of an iron in under pressing and final pressing. This is done for the opening of seams and the creasing of edges as well as for pressing garments with gathers and fullness. It is also done in cases where style changes are frequent. Pressing with an iron is common because it is simple and flexible. The next type is garments requiring extensive under pressing and final pressing. This category includes garments which require the pressing open of seams and the setting of edges during manufacture. For example, areas of large interlining, men's jackets, trousers and waistcoat, etc. The final type is garments requiring pleating or permanent press. For example, pleats in a skirt or trousers. Next, let us learn about the elements and equipment that is used to press garments and the methods of pressing. The main elements used for pressing are heat, steam that is moisture, steam pressure and vacuum. Heat. Heat is needed in most pressing processes to soften fibers and to stabilize and set the desired shape. The temperature must be selected to suit the fibers, yarns and fabrics used in a particular style. Sources of heat include heated surfaces and steam. Steam is nothing but moisture. This is the fastest means of transferring heat into the fabrics. Steam is created by heating water in a pressure or boiler. The higher the pressure, the hotter and drier the steam. Different fabrics require different amount of moisture and heat. Excessive moisture may cause shrinkage and color bleeding and must be used under controlled conditions. Pressure. Pressure is applied to alter the shape and to increase the permanency of the molding or creasing. Too much pressure may distort fabric surfaces, flatten textures and create permanent garment and or fabric damage. Vacuum. After application of heat and moisture, the vacuum sucks ambient air through the garment as it lies on the buck or pressing table. This rapidly dries out residual moisture from the garment and ensures that the set imparted by pressing is retained. Suction also ensures the garment is in place before pressing and it does not shift. Classification of garment pressing equipment. There are various types of garment pressing equipment used in the garment industry for different types of garments. Most garment pressing equipment machines range from miniature ironing boards to specialized steam machinery for different types of garments. Pressing equipment is also used in industries such as laundromats and small fabric shops. Pre-designed garment pressing equipment. Pre-designed garment pressing equipment prepares unpressed fabric through ironing before it is designed or cut. These machines are manually operated by pressing down on the fabric with a push bar that lowers the presser onto the fabric. Pre-garment presses are also used to define stitching lines in a garment before it is cut or designed. Collar and lapel garment pressing equipment. Garment collar and lapel pressing equipment is ergonomically designed to press shirt collars, blouses, coats and jackets. The pressing board is curved so that the collar or lapel of a garment fits snugly on the layout board of the garment pressing equipment. Many collar and lapel presses are hand operated. Jacket garment pressing equipment. Jacket garment pressing equipments are engineered to the shape of the jacket and are manually operated by a pressing bar. It is designed to press the inside and outside of the jacket, which includes the base fabric or lining inside of the jacket. Jacket garment pressing equipments can range from 51 inches on a flat surface to 72 inches for large coats and jackets. Sleeve and arm garment pressing equipments. Sleeve and arm garment pressing equipment is used to iron the sleeve of jackets and coats after the garment is manufactured or designed. Sleeve and arm presses are engineered vertically or as flat surface machines with the pressing boards shaped in the form of an arm. Depending on the type of the fabric the jacket or coat is made of, there are different settings for each type of fabric. These settings range from low, medium or high settings which can be adjusted by a dial or switch. Miniature garment pressing equipment. Miniature garment pressing equipment is used to iron smaller fabrics after the manufacturing or design phase. These finishing equipments consist of hand ironing devices attached to the pressing board for manual ironing. The ironing boards are flat surfaces shaped in a square or rectangle for easy ironing.
Ironing and pressing equipments include irons, presses, steamers, steam air dummies, assembling and shaping equipment and auxiliary equipment. There are equipments that operate in sequence like irons and steamers, equipments which operate in sequence and in parallel fashion like presses, assembling and shaping equipment, and in parallel fashion which are steamer dummies. Ironing and pressing equipment can be operated manually or by a pedal. They can also be powered by pneumatic, hydraulic or belt drive from electric motors. Presses with capacities up to 50 mn, that is 500 kg force, are considered light. Up to 200 mn, that is 2500 kg force, as medium, and above 250 mn is heavy. Presses are manufactured with electric, steam and oil heating equipment. Auxiliary equipment includes various attachments, forms and moisteners.
The most common but least productive ironing and pressing device is the iron, which is suitable for performing a large number of operations in processing with heat and moisture. More refined and more productive but less widespread are ironing presses, which permit a considerable degree of mechanization and some automation of processing with heat and moisture. Fabrics are steamed in order to eliminate sheen or luster, which develops when ironing and pressing equipment is used. Steaming is done either on specially designed ironing presses or presses that combine pressing and steaming, or on steaming equipment.
There are two basic type of irons, one dry iron and others are electrical steam irons. Dry irons are lightweight irons weighing about 1.4 kg with a heat range of between 70 to 240 degrees Celsius and electronic temperature controls that have a reliable accuracy of plus or minus 3 degrees Celsius. This type of iron is made in a variety of shapes and is mainly used for smoothing or finishing operations where steam is unnecessary. Electric steam irons are the most commonly used type of hand iron and carry out a wide variety of operations, especially those concerned with underpressing. The iron has a heating element and steam is fed from a central or independent boiler into the steam chamber in the base of the iron. The heat generated can be controlled by a thermostat and supplied with steam either from the factory's main steam supply or from a small boiler adjacent to the pressing unit. The steam function of the iron is activated by the touch of a button. These type of irons weigh anywhere from 2 to 15 kgs. There are several shapes are available. Narrow ones are used for seam opening on sleeves and trouser legs. For ironing of seams, especially designed iron is advantageous. The narrow sole of the seam iron and arched and narrow ironing buck avoid marks on the garment. For ironing fabrics that are sensitive to shine, Teflon shoes should be used. The Teflon reduces the contact temperature by up to 40 degrees Celsius and therefore prevents shine. We also have wide shapes for or flat shapes, or also we have pointed shapes. Irons are used on simple pressing tables. Modern tables have a supply of vacuum to hold the garment in place and dry after ironing. The pressing table can have swivel arms, bucks of varied shapes to allow the laying of sleeves, shoulders and collars.
The decisive factor for an ironing station is the airflow through the garment to cool the fabric and set the ironing result. Ironing tables are used with an iron. The textiles are ironed between the heat and the steam of the iron and the padded board.
There are different types of ironing stations available. They are jacket seam ironing station, trouser seam ironing station, sleeve seam ironing station, dress board ironing tables, all purpose tables, flat top ironing tables, blouse and shirt ironing stations, trouser leg ironing stations, hip bow ironing stations, concave ironing stations, convex ironing stations, and finally curtain ironing tables.
Padded board. In steam presses, the steam is delivered to the article through an upper ironing cushion. The working part of steaming equipment is a brush with a nozzle mounted on a flexible steam resistant sleeve joined to a steam line or individual steam generator. They consist of a static buck and a head of appropriate shape which closes onto it, sandwiching the garment, a foot. The head closes by either a scissor action or in recent ones vertically. Foot controls the head closure and vacuum. The operator can vary head pressure. A typical cycle is steam from the buck, head locked to press, further steam from the head and the buck, head released, vacuum to cool and dry. Head may be operated manually or automatically. Steam duration, pressure and vacuum can be controlled and set.
There are steam presses which can be classified as self-contained units. These units incorporate a steam boiler and electrically driven vacuum and air blowing facilities and are increasingly used both in the underpressing of tailored garments and the pressing of unstructured garments, because these self-contained units can be moved from place to place. A spring facility holds the iron to reduce operator fatigue in continuous picking up and putting down the iron.
Steam air finisher, it is also called as a puffer, a form press, form finisher or a dolly press. Work on steam air dummies is highly efficient. A steam air dummy consists of a metal frame on a firm rotating base with padding in the shape of the finished product placed on the frame. Special equipment employing steam and hot air under pressure is used to shape the product placed on the dummy.
Steam air finishers consist of a frame carrying a steam distribution system, compressed air distribution system, and a pressing form, which is a canvas bag in the approximate shape of the garment to be pressed, that is more like a body shape but with no sleeves. There are controls for steam and air release and timers to control their cycles. Little pressure is applied and whole garment is pressed at the same time. However, creases cannot be set in this machine. The operator fixes the garments on clamps. Form is then expanded to full size and steam is blown from the inside to outside, followed by hot air drying. It is used for night dresses, t-shirts, blouses, jeans and other casual trousers which do not require crease. It may require additional pressing of certain areas. Steam air dummies are used to form dresses, suits, coats, underwear and certain other products.
A tunnel finisher is a machine used to remove wrinkles from garments. The machine processes each garment through several stages. First, the garment passes through a steam chamber to make the fabric moldable. Then, wrinkles are removed by a strong hot air flow alongside the garments. Finally, the garment is dried by cooler air before it leaves the tunnel finisher. Tunnel finishers can be grouped into two different classifications, wide body or narrow body. Wide body machines are designed for high production finishing of blended garments, wet to dry, damp to dry and or dry to dry. Narrow body machines are designed for shoulder to shoulder processing and are best suited for the dry to dry finishing of garments. However, they are capable of damp to dry finishing at slower production speeds. These units are ideal for dry cleaners, hotel laundries, institutional laundries and other on-premise laundry applications. Sequential and parallel ironing and pressing equipments include highly productive machinery and equipment for unit processing and the assembly of parts with thermoplastic glues to ensure high quality and stable production. Extensive use is made of control and measuring equipment such as mechanical, oil and electronic time relays, bimetallic, fluid and semiconductor thermoregulators, pressure gauges and moisture gauges. This equipment maintains the regimens of moisture and heat treatment within the limits recommended for a particular type of fabric. Presses with electrically heated ironing surfaces or cushions are widespread, but the use of steam or of fluids that create a more even heat when mixed with hot air offers better long range prospects as heat conductors. Further development of ironing and pressing equipment envisages automation of the supervision and operation of press work, mechanization of auxiliary and laborious processes, intensification and improvement in the quality of processing, the use of vacuum to remove moisture and steam permeation instead of moistening, increased productivity, multi-operational and multi-positional presses and improved working conditions. Bugs are available in various shapes, especially in jackets. Pressing is broken in various operations. Iron is also available for touch up in local areas. There are two types of pleating machine, rotary machine and blade machine. A boiler or steam generator is a device used to create steam by applying heat energy to water. Although the definitions are somewhat flexible, it can be said that the older steam generators were commonly termed boilers and worked at low to medium pressure.
Boilers have features like a water level controller and a low water level indicator, a pressure level indicator, a unit for softening the water and a water feeding unit. Generally, the boilers can give an output of anywhere from 3 to 12 kgs of steam per hour. Boilers, steam generators, vacuum systems are all essential parts of any pressing system. Quality of steam has a major impact on production cycle time and the appearance of finished garment.
Technological advancements in pressing technology focus on greater versatility, more precision in determining exact pressing requirement of fabrics and finishes, improved quality, energy savings, microprocessors with a wide variety of settings which can control factors such as conveyor speed, steam and air volume and temperatures. Computers are used to determine settings and control the processing, so each garment is treated in exactly the same manner. Energy efficiency of pressing systems have been improved by increasing insulation to prevent heat loss. Developing self-containing systems so that the source of heat and the steam is closer to the pressing unit, including vacuum systems to reduce the amount of heat and steam needed for effective pressing. Portability has been achieved in certain systems by including steam generator and pressing devices in a self-contained unit. Automation has been made possible for bug presses and steam tunnels, ensuring consistency throughout the operation of pressing. Finally, let us learn about post finishing machines and equipment. Needle detectors are used to find the broken needle pieces which fall onto the clothing while sewing, as this can be hazardous to the wearer. The clothing brand will be penalized monetarily if such cases are found out. The first needle detector law was enacted in Japan. Due to this, all apparel importers have made it mandatory for apparel manufacturers to screen their products for broken bits of needle and any other sharp objects. If any garment is found to contain broken needle parts, it has to be either scrapped or redusted, repacked and undergo a check again. The needle detectors work on the principle of electromagnetic detection of ferrous parts, which is commonly used in all metal detectors. There are two types of metal detectors. The first one is portable handheld needle detectors and the second one is stationary conveyor type needle detector. The portable handheld needle detector is generally used in the sewing floor. It is used to check for any residual needle part that has fallen onto the garment when a needle break occurs. The supervisor or mechanic scans the entire garment or part that is sewn and the operator will be allowed a replacement needle only after the confirmation of no needle part presence. The stationary conveyor belt type needle detector is generally used in the finishing department. The pressed folded garment is checked for broken needle parts. The machine has a conveyor belt. The metal detecting mechanism is housed in a small channel over the conveyor bed in the middle. The finished garment is kept on the conveyor bed and the machine is switched on. The conveyor carries the garment forward under the metal detection channel. If there is any broken needle bits or if metal parts are detected, then the machine raises an alarm and a conveyor reverses direction and brings the garment back to the feeding position. If the garment does not have any broken needle bits, it safely passes under the channel and goes to the other side of the machine and then falls into the collection bins or is collected by a worker. Thread suckers are used to remove unwanted threads which are in the form of thread bits sticking to the garment in the fabric or in the seam. Here the operator holds the garment at one end in case of a shirt in the collar and puts the other loose end into a chamber. A foot operated pedal activates a powerful suction inside the chamber. This suction action carries away all the thread bits, lint and any other dust particles in a dust collection chamber below. This machine saves labor, as in earlier times people had to manually dust for the threads. This video shows the working of a thread sucking machine.
This is the thread sucking machine used in finishing department of a apparel manufacturing factory. The machine consists of a chamber, a lint box where the lint or the thread bits get collected. The operator holds the shirt by the collar. The other loose end is into the chamber. Pressing the treadle activates the sucking mechanism.
A garment has to be packed by the manufacturer to be sent to the retailer. The packing type is determined by product type and the retailer's infrastructure to unpack and repack in desired manner for display and stocking in retail shop. This video shows a practical working of a shirt folding machine.
This is a semi-automatic pneumatically controlled shirt folding machine. The shirt, which is already buttoned, will be kept on the table. The buttons are kept along the groove. The collar goes into the space between the hot metal head and the clamp. Activating the switch means the clamp keeps hold of the collar. Turn the folding plate to the table. Fold the shirt lengthwise as desired. Unfold the shirt horizontally. Deactivate the pneumatic control and remove the folded shirt.
This is the most important factor in determining the packing type. If the product is of formal category like formal shirts, the packing type will be a standard type which cannot be changed. For example, the packing type of a formal full sleeve shirt will be stand up pack with supporting elements made of plastic, butter paper and metals or plastic pins to create the formal look. If the retailer does not have the infrastructure to unpack, give touch up to the garments in a tunnel finisher and repack, then the packing will be required in the exact form of the retail shop requirement. There are different types of packing such as stand up pack, flat pack, umbrella pack, roll pack and hanger pack. Stand up pack. This is the most commonly used for formal shirts. The body and the sleeves will be folded into a rectangular shape. The shape is held firm because of the backing of a back support which is of the same shape kept in between. Other accessories like clips, support structures made of plastic to support the visual elements like the collar and collar band. Flat pack. Here the garment lays flat without any supporting structure. It gives a casual look. T-shirts, casual shirts are often packed in this manner. It is achieved by using a folding type packing machine. Umbrella pack. As the name suggests, the final packed garment looks like a compact umbrella. This look is achieved by rolling the garment lengthwise side to side and then twisting it at the top and bottom. Roll pack. This is mainly used for casual shirts and casual skirts. The first step is to fold the garment into required width, then rolling it side to side to create a tubular structure. This tubular structure can be either be packed or this can be further rolled into a tight bun like structure and packed. Hanger pack. This packing type is used when the garment has to be in the hanger from the moment it has been finished in the factory till it is bought by the customer. The garment will be packed with the hanger and will be hanging throughout. The packing is preferred for jacket type. This allows for the jackets to be crease free. The jackets can be refinished in a tunnel finisher before being sent to the store. Packing machines can be either semi-automatic or automatic machines with additional capability to bag and seal the folded garment. Semi-automatic machines will have templates to the required dimensions around which the folding can happen. The gripping and folding arms can be pneumatically controlled, allowing the operator to concentrate on swing arm or parts to create the fold. Automatic machines are integrated units where the garment will be fed onto a conveyor in a flat pressed form. The conveyor belt takes the garment to the folding zone where pneumatically controlled arms hold the garment in lengthwise and other set of arms operate perpendicularly to create the fold. Extra set of arms can also be deployed to get more folds. Once the garment is folded, it travels on the conveyor. At the end of the conveyor, a bagging unit is present. The bagging unit holds the plastic bag in an inflated condition. The folded garment falls into the inflated bag. From here, the garment moves onto the sealing unit where the plastic bag ends are cotton heat sealed. You have come to the end of this unit. To summarize, in this unit, you have been given an overview of garment finishing, the equipment and need for pressing garments and the use of post finishing equipment. Thank you.